the College Board loves to test on is Archimedes Principle.
Archimedes Principle.
And again, in the last 5 years, they've had 4 out of the 5 years have had fluids questions on them. The majority of those fluids questions have had at least one part asking an Archimedes solution.
Is the H supposed to be capitalized or not? What? Is the H supposed to be capitalized?
No. H is not supposed to be capitalized.
Are you sure?
That's just your talk. Ebonics, but cooler.
Yeah, I'm so lost. Looking on that one black, I just click C. I'm just gonna watch this.
Now for Archimedes, the buoyant force. Okay, now this is when when things are floating.
I learned this knowledge and tech when I was building that barge.
The buoyant force is equal to the weight of the displaced fluid. So if you take a battleship, okay,
Good looking
these things
battleship.
just have a tremendous weight because they're made out of steel and they've got all kinds of stuff in them. Provided that the battleship displaces more weight than it has, it will float.
It's a big ship.
Because what's pulling it down is its weight. What's pushing it up is the buoyant force. And provided that this is bigger than this, it will float. If this were bigger than this, it would sink like a rock. Okay? Just go right to the bottom. So long as your buoyant force is greater than your weight, then you will float. Works the same way with balloons.
Except for an air.
Okay, you got a balloon on a string. The balloon represents a certain weight, mg. There is a buoyant force, and if the buoyant force is greater than the weight, the balloon will float. If the buoyant force is less than the weight, the balloon just sinks to the ground.
Fail.
Tis a sad
The
day.
buoyant force
Oh,
is equal to rho Vg,
that's important.
where rho is the density of the fluid V is the volume of displaced fluid. And G is gravity.
Who would have guessed?
Now density is mass over volume times volume gives you mass. And mass times G is equal to weight. So when the weight of the displaced fluid is equal to the weight of the, or slightly greater than the weight of the object, then the displaced fluid will support things up. If they're equal, then you won't get any motion. In other words, with ships, that's no problem. If you have a balloon, it'll just stay right where you put it. Put it here, it'll stay there. Put it here, it'll stay there. Okay? If the buoyant force is slightly bigger, then it'll rise. Because then the net force will be up.
I'm mad I didn't get that on camera.
Which is what happens when you get a helium balloon, it's hanging on a string very nicely the first day, and then the second day it begins to droop, and then eventually it just sags. Well, what happens is, as the days go on, gas leaks out of the balloon. So this gets smaller, so this gets smaller, and so your buoyant force becomes less than your weight, and that's when it sinks to the floor. your Mylar balloons are a little bit better than your latex balloons because your Mylar balloons don't allow the volume to change as much. They don't leak as much. So that's why the Mylar balloons can last for much longer, but eventually they will.
You made the square
When you have a ship, okay,
Awesome.
your fluid is the water. Okay, so this right here is always the density of the fluid because it's the weight of the displaced fluid that is providing the buoyant force. Literally, you are pushing the fluid out of the way, and that fluid is trying to get back to where it used to be. So it's providing a force that's pushing the whatever's in it upwards. When you blow up a balloon, you move the air out of the way. Okay? It is the weight of the air, which is this, the fluid, that's been displaced, that is providing the buoyant force.